So we're going to have a little bit of fun today. We are going to I think it's a Turkish restaurant. I don't remember. We'll find out. So if you look at the top of the Circles in Zeytinyağı worksheet. So we are going to look at a pattern. Does anybody know what a chord is? And if you say anything musical, yeah, no. So if we had a line, not a line segment, but a line, and that line just barely touched a circle, it would be called a tangent line. Not a chord. Nice try. If that happens to run through the circle, it's called a secant line. Nice try again. Okay, well, if I were to cut that line off into a segment that only touched the edges of the circle, then if it were to go straight through and go through the center, that segment is called a diameter. Okay. What if it's a segment that goes from the center to the edge of the circle? That's called a radius. Therefore, a chord must be, the only one I haven't done yet, it's a segment that touches the outside of a circle but does not touch the center. So that is a chord. So among the other useless things I'm about to teach you is I can do this. No. Okay, so place 2 points on the circle. Anywhere you want, draw 2 points. How many chords can you make through those 2 points? 1. So we're going to keep a running tally over here. 2 points, 1 chord. Okay? Now add another point. Now how many chords can you draw? So 3 points. Chances are it's not a perfect diameter, so you're okay. I know your drawing skills aren't that good. Okay, so now 4 points. How many chords? So I'm up to 6. Okay. 5 points. How do you know what that is, Angelina? So 10. Okay, so let's stop there. Do you notice a pattern? What's the pattern you see? It's quadratic. Why? So if I were to calculate the differences, +2, +3, +4, and the second differences are +1, +1, so it's got to be quadratic. So we're supposed to make predictions here. I'm lazy. I'm tired of drawing chords. So I'm going to go to my calculator. How do I calculate a quadratic equation? Go into Stat, Edit, and I just need any 3 points. So 2, 3, and 4. And then my chords were 1, 3, and was it 6? And then I'm going to do Stat, Calc, Quadratic Regression. Did I teach you how to plug this into your Y1? So if yours looks different from mine and you have something that says store regression equation, go right there. If not, just stay right where you are. And I'm going to push variables, go to Y variables, go to Y1, and not only will it calculate the equation, but it will stick it into my Y equals for me. Now, if I'm outrun, don't worry about it. What? Did it work? So go back here. So quadratic regression, variables. Stat Calc number 5. Go down to store regression equation. And then you push variables right here, bars. And then go to y variables and then go to function y1. Okay, and it's all right. Don't worry too much about this because we're not going to do it again today. Yeah, then calculate. So the equation is 0.5x squared minus 0.5x. That is the quadratic equation we're dealing with. And if I want to make the predictions, they're no longer predictions, for 6, 7, 8, 9, and 10, I just do second table, and then I got to go down a little ways. There they are. Okay, don't bother writing them down. We got better things to do. Okay, so we know how to figure them out. You guys, we got it. What I want to show you is, see how I color coordinated mine? How many chords do you add each time you add a point? I add one more than you did the last time, which is shown here. One more chord for every point that's already on the circle. So when I add my 5th point, I have 4 dots to connect it to. When I add my 6th point, I have 5 dots to connect it to, which happens to be one more than the previous one. Does this list look familiar to you? What if so the next time is going to be plus 5, plus 1, so this will be 15. And the next time will be plus 6, because this is plus 1, so that will be 21. Does that list ring a bell from Friday, perhaps? It's Pascal's triangle, right? This is the first diagonal. This is part of the second diagonal. It's missing the 1. And this is the third diagonal. So in Pascal's triangle, that first diagonal, so if we look at the triangle this way, this row here is a constant row. This row here is a linear row that's created using the constant row. This diagonal here is a quadratic equation that's created using the linear diagonal next to it. And this is an x to the 3rd, and an x to the 4th, and an x to the 5th, and an x to the 6th, continuing on forever. Okay? All right, so I hope you wrote the equation in number 6. 0.5x squared minus 0.5. All right, now for the fun part. So I just did that to show you that Pascal's triangle has a ton of uses. And we're going to use it today for probability. So let's say A, B, C, and D are in a group. So imagine these are people. And you were to choose 2 of the 4 letters or people to go in a group. How many different combinations are there? Before you answer, what's the difference between a combination and a permutation? One of them you can switch the order without switching the scenario, and the other one you can't. Which is which? Combination you're allowed to switch. So basically it's saying a combination is saying AB is equivalent to BA. Can you give me an example where that's true? Shaking hands is a really good example. If I shake your hand or you shake my hand, it's the same process. Okay? If that's not true, we have what's called a permutation. So AB is not equivalent to BA. Can you give me an example where that's the case? License plates. That's a really good one. If you have license plate AB and I have license plate BA, we have 2 different license plates. So phone numbers, zip codes, combinations or permutations. The starting 5 of a basketball team, combination or permutation. It depends. If I say you 5 get to play today, you 5 get to start, combination or permutation? That's a combination because I haven't designated any order yet. But if I said, you're the guard, you're the center, that turns it into a permutation. Does that make sense? Okay. If you are playing the lottery, which in a lottery they have a bunch of ping pong balls, you pick 6 numbers, and 6 random numbers come out. Is that a combination or a permutation? It's a combination because they actually just put them in small to large. So if you put 6 on your ticket and 6 shows up somewhere, that counts as a winning ball. Does that make sense? So lotteries are combinations, not permutations. Okay. So if I had these 4 letters, how many ways are there to put them in a group of 2? So we could calculate, it's either 4 choose 2 this way, or it's usually written like this. So 4 choose 2, if you look at the triangle, 1, 1, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. So this is the row I'm looking at. The first number is 4 choose 0. How many ways are there to choose none of the 4 letters? 1, you leave them all out. How many ways are there to choose one of the 2? 4, or one of the 4, sorry, 4. And the choices are, you either pick A, you pick B, you pick C, or you pick D. I only have 4 choices. But when I go up to 4 choose 2, it equals 6. What are those 6 possibilities? So AB, AC, AD, BC, BD, and CD. So there's 6 ways to do that. What about 4 choose 3? So this answer here was 6. What about 4 choose 3? Why are there 4 ways? So if I were to create those 4, it would be, let's see if I can do this, ABC, BCD, ACD, and ABD. What do you notice about this list and this list? They're the same size. Why? I can match these up. This one doesn't have an A. This one doesn't have a B. This one doesn't have a D. And this one doesn't have a C. So whenever you're picking combinations, you're actually splitting the possibilities into 2 groups, the chosen, and the not chosen. And when your chosen equals your not chosen in different problems, then the answers are going to be the same. And you notice that on the entire triangle. So 7 choose 2 is equivalent to 7 choose. If I have 7 letters and I pick 2 of them, that's going to be the same as 7 choose 5. And if you look at the triangle, 7 choose 2 is 21, and 7 choose 5 is also 21. Because when you pick 2, you leave 5 out. So when you pick 5, you leave 2 out. It's going to be the same calculation, either way. Okay, so we need to answer, what about all 4 letters? 1. Why? The option is A, B, C, D. So choosing everything is exactly the same as choosing nothing, as far as possibilities go. Okay? All right, let's eat. So Tom and I put this together. Well, he mostly put it together, and then I brought it back into reality. So Talent, which is Tom's oldest son, and Tom went to Washington, D.C. They ate at Zeytinnya Turkish Mediterranean restaurant. Meze-style dining is small plates of food to share, and you order a variety. I can't see the rest of that. Usually about 3 dishes per person, and no 2 people order the same dish. So you probably never even heard of Meze-style dining. You go and you order for the group, and you figure, I'll eat just about this much food, and you pick a couple things on the menu. They throw it in the middle of the table. So does everybody else, and then you just sample everything. Okay? So I'm going to put you into groups today, and you're going to be ordering off this menu. But first, let's look at what Tom and Talon and there was another person there ordered. So, if you look at the menu, where did my menu go? They ordered 2 spreads. So if you look at spreads, there are 7 of them, and you probably want to write that down. Spreads they're kind of these cheesy, dippy, yummy appetizer dishes, and they come with like toasted bread that's been cut really thinly, or crackers, and you dip it in there and you eat it. So you see hummus in there, that's one of their spreads, and a whole bunch of things that you've never heard of before. So there are 7 of those spreads, and when Tom and Talon went, they ordered 2 of them. Now, I'm not sure which 2 they ordered. All we know is it was 2. For soups and salads, there are 8 soups and salads, and they chose 2 of them. Some of them look pretty good. Beet salada, no thanks. I don't do beets. Flatbreads, there are 2, and they ordered 1 of the 2 to share. Then if you turn the page, there are 20 vegetable dishes, and they picked 4. And then there are 12 seafood dishes. Some of those look pretty good. And there are 16 meat and poultry dishes. So, they ordered 2, 4, 5, 9, 12. So they ordered 16 different dishes. Now that's a lot. I'm sure they didn't eat it all for just 3 people. And you set it in the middle, and everybody tries everything. That's kind of how this works. So what we want to know is, without actually knowing exactly what they ordered and only knowing the categories, how many different ways could we put together an order that fits these numbers? And each one is its own combination. We just have to go through and calculate them. So of 7 spreads, they ordered 2. So what is 7 choose 2? We go up to the chart 21. Okay. The next one, what is 8 choose 2? 28. So this is telling us there are 21 different ways to order 2 spreads. You could order the hummus and the labneh, whatever that is, Lebanese strained yogurt. Sounds good. Or you could order the hummus and the baba ganoush. Ooh, you're right. Okay, so, and there are 28 ways to do this. What about 2 choose 1 for the flatbread? So 2 choose 1, it's going to be 2. And for the veggie selection, 20 choose 4. Well, I don't have row 20 on that triangle on the wall. So we got to go to our calculators. And you push 20, and then go into math, and over to probability, and there's an NPR and an NCR, and we want the C for combinations. 20 choose 4. 48, 45. So 48, 45, that's for the veggie selections. The seafood is going to be 12 choose 3, which I can find on the wall. That's 220. And 16 choose 4. I need the calculator again. 1820. So 48, 45, 220, and 1820. Now, each of those numbers only tells me the possible combinations for that particular category. How do I find the total number of combinations? Do I add them or do I multiply them? Why multiply? This is a really hard question to answer. That's a really good way to explain it. So 21, this tells me how many different ways I can order that. What if I keep my spreads the same and I change the flatbread? Is that going to double my number of possibilities? Yes. So we need to multiply. Changing one item on the list changes everything. So we're not adding them together, we're multiplying them together. And if you do that, 21 times 28 times 2 times 48, 45 times 220 times 1820. Oh my goodness. So I want you to write it this way. 2.2 e to the 12th. What does that mean? I need to move that decimal to the right 12 places. It really is 2.2 times 10 to the 12th. And each 10 moves the decimal one place. So I need to move this that many times and fill those in with zeros. Now if I put my commas in there, so hundreds, thousands, millions, billions, 2.2 trillion ways to order at that restaurant. So chances are, if we did this at random, none of us would pick the same stuff. There are 2.2 trillion ways to create that order. Okay? So, turn to the next page. You are going to come up with 3 orders on your own. For this first order, you will be in a group of 4 people. So choose how many of each type of item you're going to order. You need to order enough food for the entire group to share. Portions are small, so you need to order 3 orders for every person. Also, you cannot order the same dish twice. So when you sit in your groups, go through and pick the 3 items you want the most. And then double check and make sure nobody picked what you picked. If you do, you have to pick something new. Okay? And then you're going to go through and total up your categories. So when you add up all the categories, it needs to add to how many? 4 people in a group, 3 orders per person. It needs to add up to be 12. And then you'll go through and you'll do each combination and multiply them all together and see how many possibilities there are for your particular group. Does that make sense? Once you finish part 1, so you'll have how many total combinations calculated, go on to part 2. If your group size were to double to 8 people. Now, at this point, you don't really need to look at the menu. You've kind of got a sense of what's in there. So for 8 people ordering 3 items, what should our category totals end up to be? 24. So as a group, you just need to decide where are we going to put our 24 entries. And once you have it in there, there's some questions down here. How many total entries are placed? How does that number compare as a ratio to that in part 1? So let's say this one was 5.6 e to the 9th, and this one was 7.1 e to the 13th. How do I find the ratio? Just divide the two. So let me show you how to do that. So if I did 7.1 times 10 raised to the 13th, I recommend you just push enter at this point. And then you're dividing 5.6 e to the 9th. But you want all of that included in the division, so you're going to need parentheses. So divided by 5.6 times 10 raised to the 9th. What does that number mean? My second order is 12,000 times bigger than my first order. Does that make sense? And then you're going to do the same thing for 16 people, and you're going to find some ratios. Okay? And then there are some questions about maximizing and minimizing. You can do that tonight on your own, and we'll talk about the answers tomorrow. So before you leave, you need to pick your categories for part 2 and part 3. Okay? And then your assignment tonight will just be to finish that paper. And we'll talk about maximizing and minimizing tomorrow. Okay? Good luck.